We have great pleasure in presenting Lieutenant General Dr. J Sundaram to you, ladies and gentlemen. Dr. J Sundaram obtained his ME in Mechanical from University College of Engineering from Mysore University. He joined the Indian Army in 1957, standing first in the Technical Graduates course at Military College, Dehradun. He worked on border roads in Jammu and Kashmir under 15 Corps as well as the Northeast. He had tenures in EME training centers and headquarters, 26 Infantry Division as well as commanding a field workshop in 39 Infantry Division. After undergoing courses in telecommunication in EME and guided missiles at Institute of Armament Technology, Pune, he joined DRDL in 1968, where he has been head structures environmental, testing and missile assembly, as well as director propulsion. While in service, he completed at IISc ME in Aero Distinction and a doctorate. His research areas were stress analysis of solid propellants using finite elements, photoelasticity, and holography, as well as failure of viscoelastic rocket propellants under stationary and non-stationary random vibration. He was awarded VSM in 1980 for his work on India's first surface-to-air missile. We present Dr. J Sundaram and for his keynote address.
The one thing which I have been finding after, as I said, I became an engineer in 1957. It's now almost more than 55, 56 years. And now I still go for some reviews. And I find a little bit of disconnect in what I call system engineering. And though your computers, we had no computers then. But today computers are there. But I do find a little lack of system. So my talk would be towards self-reliance by system engineering. That's what I would like to talk about. Okay. You see, in the 1600s, India was fairly self-reliant. We had our guns. You can still find them in Bijapur and other places. But gradually, over a period of time, we became convinced, or we were convinced, that India can produce only food and some cotton. And we cannot produce anything for the defense as such. And by the time we were independent, we were almost zero. Nothing really came from India itself. After that, gradually we had the Green Revolution and we had the Milk Revolution. And little by little, certain of our public sector were set up. And we achieved a certain amount by contribution by Indian industry as well as R&D, both public and private, which was done. Now, as I told you, after the Chinese war, we had some surface-to-air missiles supplied by Russia to the Air Force. But very soon, maybe we did not agree with them fully, they stopped giving some spares. So all these missiles were dead ducks. They were not operational in the late 60s. Again, it's something which we cannot talk about at that time, you see, but this is a fact. And this is the time the Air Force let us do something of our own, and this is where the political will comes in. I say, for anything to be done, the political will and the government comes in first. And that's why today I'm so happy that we have Mr. Jayachandra here, who realize that unless that political will is there, the country is not going to really become self-reliant. I am reminded that just this year, they said, oh, you must indigenize. And then I saw the allotment of the finance minister to the 1 crore. If you think indigenization come by 1 crore, we are sadly mistaken. So it cannot be held by just talking on the outside, it has to be implemented. Okay. Anyway, it was Mr. Venkatraman and Indira Gandhi who had the political and foresight to sanction the missile program, which they felt cannot be done. The general view is, how can India make missiles? So, but something has been done. The Prithvi, Trishul and Dr. Kalam took over this program as a whole, and I had the good fortune to be associated with the Prithvi, and whatever we did was by collaboration with the government, R&D, users, academia, and industry. We talked about innovation. There was a certain amount of innovation, I would say, in this program, right in the organization structure itself. In the board, apart from the chairman or the scientific advisor, we had the secretaries of defense, finance, expenditure, revenue, and defense production, all meeting once in 6 months, and they could take decisions. And they had the vice and deputy chiefs of the financial attendants of the services, and the chairman of HAL, Bell, Ordnance Factory Boards, BDL, they were there, and the final financial advisor. So this was one part, take final decisions. Because the main problem is we don't take decisions easily and takes time. At the same time, development is okay, we have to produce. So we had a production management committee with again the industry people, and cost has to be controlled. There was a cost control committee, and all these were working synergistically together. This is one program structure which was, I think, came out in 83, 84. It was not there like this earlier in any program, and it's helped quite a bit. Of course, we had the others, the working board where the project director and the program board that was there. But this was very, very important, and I congratulate whoever was done in government at that time to have brought out this organization. It's not so easy. Again, now I find it's not happening. Okay. So on the Prithvi, we had a philosophy. Again, I was fortunate to be made the designed the system, led the design team, and I was also made the project director later. My philosophy was you will have a maximum indigenous components, but to a specific standard. I said quality is free. Many will disagree with that, but I can tell you it is. Then I said follow all rules and regulations and to get the user involved with you. And system engineering and concurrency was one thing I projected. And a transparent collaboration with the academia and industry, and give realistic time, cost, and manpower. And I said the design guideline should be designed for Six Sigma. The failures goes down. And in production, involve all major productions right from the start. When I put down all this as my philosophy, people said, "Hey, this is a utopian concept. Hai. Your project will not take off." That was this thing. And even Dr. Kalam used to tell me, I say, "You are all funny guys." But he never said no. He supported us. I must tell you that. That's one thing which a leader must. So it was the funny guys who started this particular program and went our way in all these things. Probably the philosophy, but as thing goes, the PD will mellow and do that. But let me assure you, I did not relax even one of these. And people understood that this project that is not going to relax. And people followed. It was done. Times when I projected, they said, no, this is too long. But I said, this is my time, and we stuck to that time. Whatever time, reasonably. We said first flight in 4 years, 6 months. We did it in 4 years, 7 months. So, then gradually realized this project is reasonably okay, not all that bad. That's what happened. Okay. So, in system engineering, the user just gives you something, but that is not enough. This is, I want 150, you give me 1 ton, that's not enough. You have to look at all the technologies, reliability, maintainability, lifetime cost, and what you're going to dispose it of after retirement. I'll come to that at the end also. Then you make an operational model, and then you go into a detailed design. It takes some time, and for some time people will say, "Kuch nahi ho raha hai project mein." Yeah, what are you doing? But you have to accept that, okay? Then the systems goes from concept till retirement. I want to stress that. Design, development, testing, life cycle support, deployment, training, it covers everything. If you do not do that, your project will be a success as a little demonstration, but that's not our aim. The product must move to the user. So the aim I laid was, you have to give missiles to the regiment. You have to raise a regiment which will be deployed against, whoever doesn't quite agree with you. So you have to raise that. So that means you're not producing 1 or 2 Prithvis, you have to produce 200 Prithvis. That is this thing which had to be done. So production comes in a very big way. So this was what we insisted. And for system engineering, I formed a committee. It had never been done before, which brought in the aerodynamics, structures, control, electronics, propulsion, the integration. Now we had system managers. That was one part. And I said, you will meet every Saturday. People said, every Saturday, koi nahi aayega, saab, koi nahi aayega. I said, you meet, we will see. Again, there also gradually you found 1 or 2 who are not coming. You politely ask them what happened on Saturday. You're not well or something. Next time, please note, I was not on the system engineering committee. It was somebody else. And I was looking at it from the side. We had a small core group. I was the chief designer. And Dr. Saraswat was my deputy. He has just retired as the scientific advisor today. And many of the people who are sitting here as project managers, they've all been directors of laboratories or CCR&Ds. Prasadra was chairman, NTRO. Like that, they all rose to various positions. But other job was, along with this, had to maintain human relations also. So the job of PD is also to bring these people together as a total team, as a teamwork that is required, and that is what we did, because also was restricted. And whatever recommendation has to come, it is the project who took the decision one way or the other. and that is how we went along. As it was slightly slower to start with, but it helped us to form the technical strategy right through from design, development, supply chain, production, maintenance, and operation. I remember taking Professor A.K. Rao and getting some of the missile operators, the soldiers. Professor, finally I have to bring it to this stage. He doesn't know anything else. He says number 1, number 2 read, number 3 read. That's all he says. He operates the switch and it has to fly. No question of looking what happens to aerodynamics, whether Bernoulli's flow is there or this thing. No, it has to operate when press the switches. And I say it will operate without an officer. It will be done by a JCO. See? Okay. As I said, the missile technology control regime came into force, and I must also tell you, it is still in force. It is not being acknowledged at the higher levels. It is still in force. And so we utilize the indigenous knowledge, innovation, R&D, labs, academia, and interproduction. And the other thing we did was encourage people at all levels to think differently and experiment and study in other areas. They suggest, so there's new ideas. When I say all levels, I mean right down to a Kalasi. I can tell you, a Kalasi has given us good ideas. In various places, sometimes in Calcutta, sometimes in Vizag, when you go on the shop floor. Parichayatulandi, itla cheste vachestundemo chudandi. Vizag man has told me. And we were able to solve some of these problems. Some results which are Indian first, I must tell you, missile-grade sheets and plates, aluminium, magnesium, and titanium, a digital flight control system, a strapped-down inertial navigation guidance system, hydraulic servo valves and actuators, and a microprocessor. These, again, we could not talk at that time, but today I'm telling you, these were done. And when these were done gradually, we were able to not only do your project finish, but they are in service. Today, they have gone to all the 3 services. So when we did the first launch, because Dr. Kalam had told us you are funny guys, the people put up a placard saying funny guys. They have done it. That was the first flight which was done. It was all in good humor. And the great thing about Dr. Kalam was he would listen to ideas which are contrary to what he thinks. That's this thing of which is what I would request many of you also to bear with. Sometimes your juniors may think, look at it. Even at the lowest level, maybe a sweeper. He has some good ideas. Please think about it. Okay. Then we did a system life cycle testing. It is a lot of effort, no doubt. And right at the start, we also anticipated on future needs. What was in green, that is what we delivered. But what is likely to happen, say, 20 years from now? We thought of that. The range was increased to 250. 25 years, they wanted a range of, we started 150, mind you, and today, the Prithvis are flying 350 kilometers. And we have started with conventional. Well, I don't agree with it, but the international national arena demanded. Now they carry nukes. I must tell you that. So what was done at that time, it is now flying in many places. It's gone to the Army in 94, Air Force in 2002, and Navy in 2007. Now it is 20 years since these were inducted, and they're still there. This is what I meant. You have to take it up to the life. Particularly an Army product, you just don't make it and throw it. It's not that today you bought a Maruti Suzuki, Maruti 800, and tomorrow you go on to something else. Today you have a Swift, then you have something else, then you have something else. That doesn't happen in the, we cannot afford it in the difference. It has to serve for some time. And the minimum, MiGs are still flying, okay? All right. Then this is moving on the ship, on the P-51. In fact, then this is also used to develop the anti-ballistic missile concept, and this was done much later, 96 the concept started, and it was flown in November 2006, which was done. And you can see again here, you see Prithvi is as a ballistic missile as a target, surface-to-surface missile. We also have a Prithvi air defense interceptor, which intercepts that in the ballistic mode. Now, there's a little bit of innovation. This is a surface, well, on the ballistic is surface-to-surface, and Prithvi is a surface-to-air, which goes at a much higher speed. All that innovation done here was to put where the warhead was, we put a smaller warhead with a second stage. But basic missile, you can't make out a difference. They both look the same, except a small change in length. And a lot of these internal tests which were required were done by Dr. Prahlad. He's sitting here at NAL. Use that. And that's how it was done. We thank NAL and a lot of other people who did this work for us. And this, of course, you can say, I was with the enemy. because nobody wants to launch the enemy missile. Somebody has to launch the enemy missile if you want to test. So I was the mission director for the enemy missiles also. So totally I've launched about 49 Prithvis till now, from 1988 till early this year, including... So, but now I think they're going to release me from that little thing so they can relax and watch your flight without butterflies in my stomach. Because till the thing lifts off, there are butterflies. Where is it going to stop? I can tell you that. So, this is, as I said, both the interceptor and the enemy missile. So, here you have collaboration everywhere. So, here you're collaborating with the enemy, so to say, from our side, or to that, or to that. And you can see where the gamut it has gone from a Prithvi 150 to 350, ballistic missile, air defense, and all by certain amount of innovation. Every stage there's a certain amount of innovation. I don't want to get into that. Right through, innovations have occurred again from at all levels which have happened. Okay. Now I'll go on to something else. I'll leave the Prithvi. It's still flying around. And look at a defense network. And part of one of the items of the defense network are the mini and micro air vehicles, which we have started at ADE and NDRF. So from mini 1.5 and micro 300, which is now going on for the particular places, for disaster management, low intensity conflict, as well as R&D, we could use this. And it's based on knowledge which we had from research onto industry, unstudied aerodynamics, in-state aerodynamics, fuel cells, going on to brain-machine interface. We have started working on a brain-machine interface now, and vision-based devices. Jarna is here. Where is Jarna? You've gone some. Okay, she is the other people also doing vision. Ah, there you are, Jarna. So we depend on these people. We have got Ramaya, we have got Venkatesh, we have got so many people here I can see who have been helping to this. Because again, when we started, it was like missiles. Ab India may are going to be micro, no. Israel can do, US can do. India can't be done. Today we are doing. We are flying at NAL, a 6-inch gadi, you see, which is there. And we have a small company called DC Enterprises, which makes micro motors, 2 grams, 1.5 grams. These again were denied to us. And then we came to know that these motors, somebody is supplying from Bangalore to Europe and USA. Where are they coming from? From Banshankari. They are supplying to Europe and USA, and they will not give it to us. But once it was open, now we don't have a problem. All I want to say, technology is once you do it, then you start getting it at sometimes slightly lower price. You have to beat them by competition, as he said, which is to be done. So this is again an innovation which is done by DC Enterprises, and as a societal application, it can be used for disaster management. It could have been used in Uttarakhand if they brought it in. And this you can see the collaboration. You have the user, you have the academia, R&D labs, Tata as well as industry. You have the SP of Kolar from the police who will use it, the National Disaster Authority, and those boys with the red and the boy with the long hair. He was the one who made the little helicopter which you might have seen in the Three Idiots, you know. He did that. 3 Idiots, how many have seen 3 Idiots? Almost all of you must have seen. You see that little helicopter, quadrotor which goes. That was done by Ashish Bhatt of Idea Forge. And they do this little bit, which is there. But one we're very, very, very weak today is the sensors. This is where again you look for collaboration against in the micro, bio, nano, info, and cogno. Not only within India, biological labs, nano labs, institute, various other places, we are going abroad also. Just now we had Professor Muthukumaran, he had a small device for sensing ammonia. I know it has been made with collaboration with, thank you Professor Muthukumaran for having done that, because right now we don't have that. We have a fair amount of fab facilities, but we need a little more. But we're not waiting, we're taking them. HR is there, you encourage them, we don't have to hold on anything. Since are there, we would go on to more. It can also go on to whatever technology can be developed. I am requesting Professor Muthukumaran, why don't you use it for early detection of cancer? There are antibodies and all putting it down. And you might ask, you know, that what is this? You are a mechanical engineer, and this is our olfactory sensor, like a human body, to sense dosas and idlis being supplied outside. And this is an enzyme biosensor, making use of enzymes being done by NDRF. Now, by actually Prashanti. And Prashanti is a mother with 2 children, mind you. She works part-time. Whenever she can spare, whenever the children don't trouble her, she works. We allow that little bit of, it's not only MNCs who have flexi timings, NDRF also has flexi timings. So whatever you can contribute, you contribute at your time, but contribute. That's what we look for finally. If you don't contribute, then we'll say goodbye. But you contribute at one time to the best of your ability. She's done microbiology in Stanford. She was here at Luzon. Help us. She's helping us, along with big tech. I think one of them is going to supply also here. So, and then we're looking at a cyborg, like our, we had in Star Trek, we had a cyborg there, we had Spock. So, but this is a butterfly, part human, part this thing, we're looking at it like that. So, we are looking further at using a crawling beetle for going under buildings which have collapsed. It happened in Uttarakhand. So, we call it, so we have gone to the Institute of Wood Science and Technology and University of Agriculture Science in Raichur. You may say engineers on one side looking at agriculture, we're looking at wood science. I would say this is collaboration. You have to bring in, you have the JNC looking at height this thing, you have the PISOs, you have the NDRF. So there are many things which can be brought together if you really want to innovate and do whatever you want to do. And one last bit I just want to ask. How many of you are using CFLs in your house? CFLs? Everyone. Now what do you do with the fused CFL? Throw it in the rubbish heap. It is highly poisonous because it's mercury. That's why I put this down. Today we have here manufactured. Then it is today mandated by law that you must collect and it must go back to the manufacturer for proper disposal. So, but it's not happening. You just put a rubbish heap. And today we are sitting on a time bomb of mercury poisoning of our children and grandchildren. Because it's going into the ground, it is going into the water, it is going into the food. And luckily, our chief guest today, Mr. J Chandra, has looked at food, he has looked at environment, he has looked at law. All of them are involved. I request, I've been telling this many times, and the law exists through the PCB that it must be done. So, one small innovation I would say is the housewife or husband, whoever is there, either give it to the waste collector, give him some 2 rupees. He will be happy to collect it. Or you buy a rebate like you do for your battery. When you buy a new CFL, they say, if you bring a old CFL, I'll give you 5 rupees rebate. I can assure you, the housewife will make sure that no CFL is thrown like that. She will ask, 5 rupees sikta illa nimge kottide kya? She will keep asking. So this is my suggestion, if you could enforce that and recycle and do that. And I would only say, in the end, for success, first is the aim. You want to save your country from the mercury poisoning. It has already happened in Kodaikanal. It has happened in other countries. It's happened in Minamata in Japan. You have got the poisoning at Fukushima. You are looking at Kudankulam. But this is a silent poisoning happening and nobody is raising a voice apart from anything else. You be realistic, do system engineering, and generally I would say, I use the word responsibility, not accountability, with authority, and encourage people to disagree with you, then do an experiment and suggest new ideas. I think many things can happen. What do you say, Ramakrishnan? You have been around quite a bit. Huh? So this is my request to all of you. And maybe from today, we'll get some move on the CFL. Please, I have got about 17 CFLs stored in a polythene bag, waiting for the day when somebody will collect it and recycle it. Thank you very much.
Our hands once again, thanking Professor Sundaram for his entirely inspiring talk to us. Thank you, sir.